Welcome everybody to my session about serverless microservices, serverless architectures. My name is Niko Köbler. I am a freelancer from Germany, and currently I'm more in the cloud at home, at my actual home. And if you want to find me on Twitter, just have a look to Das Niko, also printed on my back. And yeah, let's start. Talking about serverless. Before I start with my actual talk, I have to tell you a disclaimer. Serverless. No matter what I talk about, serverless is not the silver bullet, it's not the holy grail, it's just a tool which fits into a special need. So it's not recommended as a tool for everything. And serverless is quite a bad name for all the thing I'm talking about, but it's just a name. Earlier this day I saw a tweet about something like Gitless. It's a versioning system on top of Git, but it's called Gitless. So this less thing seems to be a thing these days. And Werner Vogels, the CTO of Amazon, last year at the reInvent in Las Vegas said, no server is easier to manage as no server, and that's what it's all about. It doesn't mean serverless, you have no server, you don't have to manage servers. And actually, this is what serverless really means for your operations or your IT technicians in the backbone. There are tons of servers which you have to provide, which you have to facilitate to make all this happen. So serverless, it's all about the management of servers. And how could all this happen? That we don't need to manage servers, because the server, the application servers, our big loved thing. And few years ago, we have our monolith. Cool things. One application contained all what we need, application server, whatever. And then, after a while, we started building distributed monoliths. Okay, having some same thing at multiple places. And then the self-contained systems came up. Whatever this means, but it seems to be also a little bit smaller than distributed monoliths. And of course, microservices came up with a bounded context. So we have boundaries. With monoliths, we have no boundaries. We can do all what we want to do. But with microservices, we have this bounded context. We have boundaries. We are also smaller. And we have this thing, platform as a service, backend as a service. We have nothing real under our hands. The monolith we all know, and now we're getting smaller and smaller. And yeah, what do we have now? Yeah, finally we have FaaS, function as a service. And this is what most people associate with serverless. Function as a service. Functions in serverless environments are running our own code in an external sandbox, stateless, and transient compute container. And we don't need to care about an application server, and we don't need to care about Docker. So just again, the first sentence, we have some function code running in an external and sandboxed environment. So you can think about something like a Docker container. So starting up a Docker container with your own function you're writing, executing the function, and shutting down the container and forget about the container. But actually, it isn't a container. It is a container what is used, but it's not a Docker container. So Docker is even bigger than functions are, just pure functions, nothing more, nothing less. And when thinking about functions and just running your code, many people say, what's the difference between functions and serverless and platform as a service? Platform as a service also provides me all the things. Yeah, but when talking about platform as a service, you have to manage the applications. And when talking about function as a service, you have to manage just functions, not whole applications. And this is what I say when platform as a service is kind of DevOps, and functions as a service is kind of NoOps. You don't have to think about all this management. You don't have to think about scalability. You don't have to think about availability. This is all your provider, your cloud provider, will think of. You as a developer just have to think about your code. And Amazon Web Services has made it very public with, very popular with their service called Lambda. What is Lambda? Lambda is an architecture which is event-driven. So Lambda just runs your code in case an event is emitted. And you can use any JVM-based language, Java 8-based. You can use JavaScript and Python. Currently, Amazon is thinking about more languages to launch. And you're not just bounded to Java. You really can actually run Scala code. You can actually run Groovy code, Kotlin code, or whatever. You just have to provide the runtime itself along with your code. Because Lambda itself provides just the JVM. So you don't have to provide the JVM, just have to provide your code and a possible runtime environment. And your functions are organized in several versions. So you can have multiple versions of one function in parallel. And all the versions have aliases, and they are managed with RANs. RAN is the Amazon resource name. So you can have multiple versions of one function in parallel, identified with RANs. And so you can invoke different functions with these RANs. And last but not least, Lambda is a very cheap possibility to start up with your needs. So Lambda is calculated on a time base of 100 milliseconds, execution time, and depending on the memory you need, you have a real cheap price of some zeros after the dot on the right side for one execution block. And additionally, the first, I think, million call per month is free. So you have to have a real massive amount of execution blocks per month to get into a higher price. How does a Lambda function look like? So if you program it in JavaScript, you have something like that. You have just a function. Can you see this pointer? Yes. You have a function which takes an event object and the context itself, and then you go. You just do anything with your event which is emitted by the infrastructure. And similar thing in Java, looks a bit more, because we all know Java code is a bit more to go. In Java, you have something like a request handler. The request handler takes a request and a response object. And with the request object and the context, we have our method. We have a single method which is invoked from outside. And then we can do anything what we want on this event and with the context, and just returning an object or returning a null, void, whatever, if you don't need a return value. And there you go. nothing more. So this could be really small to have something like a microservice running. Or perhaps it's just a part of a microservice. Perhaps it's just a CRUD service or whatever. As I said, Lambda is invoked by events. So every Amazon service is emitting events, is able to emit events when something happens. And Lambda can react on all these kinds of events. This is just a selection of all the services which are possible. Popular example is if you put an image on S3, on the storage, S3 can emit an event. There's a new image. Lambda can react on that event. So there's a new image. I take the image, calculate some thumbnails or other resolutions from it, and put it also in another bucket on Lambda. So this can be fully automated. And so you can react on DynamoDB events if a new document is saved, if a document is updated, whatever. SNS, notifications from outside, emails from outside, whatever. And the last two, the API Gateway and the cron jobs, are very interesting. The cron jobs, as it says, you can run your functions scheduled. And that's what we do at our local Java user group. We always forget to send our invite emails to our members. And so we started to put it into a Lambda event, which runs scheduled every day, looking in our calendar for events. And if there's an event a week before, the Lambda function will send an email to all our members. And the another thing is the API Gateway. With the API Gateway, you could turn the Lambda functions into something you can talk with over HTTP. What is the API Gateway? You can think about of an API Gateway as a kind of a reverse proxy. So you can have several services behind the API Gateway. And this gateway can hide possible multiple server calls. These are things we know from the past, from service composition or something like an ESB. There are companies offering ESB. Formerly, they called it ESB, and today they call it, hey, we have an API Gateway. It's much about routing requests to some backend services. API Gateway can distribute the requests to several service instances which are in your backend. And this is kind of a thing what Netflix does. Netflix has an own API Gateway, and on this API Gateway, Netflix has several endpoint adapters for all of the different for all the different devices they were able to use. And you can also think about having these endpoint device adapters at the back end of the API Gateway, distributing it to dedicated services for each device. And an API Gateway can be very helpful if you start developing your API. You can provide just mock data. Your API is already live, and you can provide it to your partners, which should use the API, and just providing mock data. And if you're finished with your implementation of the actual services, you can just put the services to the gateway and delete the mocks. The Amazon API Gateway is possible to have authentication and authorization via our own AWS services like Cognito and Secure Token Server. And you can configure the API gateway for different environments, like staging, production, test, whatever, with key-value pairs. So you have to do the actual configuration one time for the routing, and then configure with key-value pairs for different environments. And this is how the UI, how the API gateway can be configured. And let's have a look to a real-world, not really real-world example, but a running example. I have my AWS Lambda, and this is the editor. In Amazon Lambda, I can edit code directly if it's JavaScript or Python, or can upload zip files or reference files from S3 to act as source. This is just JavaScript, so I can edit it online. This is just a service connecting the requests to DynamoDB, a NoSQL database at the backend. And we have here some different HTTP methods: delete, get, post, put, and putting the payload to the database or getting the payload from the database. And this Lambda is configured that it's triggered by an API gateway, actually. Strange.
The trigger for the API gateway is unless to the Lambda in the API gateway, not in the trigger for the Lambda.
It should be displayed at this point. Yesterday it was displayed. Okay. That's because I'm wondering there's no trigger, whatever. And it's configured with a runtime, the Node.js runtime, because it's written in JavaScript. And as you can see, you have Java 8 runtime or Python runtime. And you can specify the handler method, which will be invoked when the Lambda is started. And if we have a look here, we have the exports handler. And this is the same handler method called on the index file. Yeah. Additionally, you can choose some memory, maximum memory you will consume, and of course a timeout that your Lambda function won't run endless, and you can have some control over the costs at this point, because your Lambda function is intended to run very shortly. So then we have an API gateway, and there's a possibility to use something like a Lambda proxy. And with the Lambda proxy, the API gateway routes all the whole request as an event object to the function itself. And this is what we receive in our function with the event object. And here we see the Lambda is connected to this API. And then if we go to the stages where it's deployed, I have just a prod environment. I can get the URL from the system where it's deployed, where I can talk to this API. And then if I start my Postman to run the requests, the last part in this example is just stating the table name of the Dynamo database. And so we try to get all the entries in this table, in this demo table of DynamoDB. And if requesting it, and hopefully the network will do, yes, we're getting a count of 0 and an empty array because the table actually is empty. And if we now just put some kind of object into the table, should work. The response is below. Nice. There's an error. Okay, this was indeed unexpected. I won't dig into a debug mode now. This is, yeah, there's no entry written. However, you should have seen the object. I send it here in this request now in this GET request, but however, it does not work. However, just because I edited it in the last moment before my talk. No. There it is. So you just have to believe me, unfortunately. It will work. Yeah. This is the API gateway with the connected Lambda. And if you can see here with my other Lambda, this is the send invites Lambda I talked about for our email sending request. And it has a bit more of data. That was 1.8 megabytes of data. And this is because I'm using further libraries to sending out the emails and to parsing iCal entries. And I can provide all the libraries, the third-party libraries, along with my code. And as you can read, if this file will be edited in the online editor, all the third-party libraries are gone because they're uploaded separately. So I would have to change it in my local project and load it, do a complete upload with all the libraries if I have to do a change. And this is similar how you can upload complete Java functions which need third-party libraries. Okay. So what are further use cases? This is a small example how a complete web architecture might look with serverless services. So in this case, our user is sitting at his desktop computer requesting a website, and all the static content will be delivered from CloudFront and S3 storage system. And as soon as the server requests some dynamic content from API, mywebsite.com, the Route 53 service will route it to the API gateway. And behind the API gateway, there are Lambda functions and data store. This data store can be a DynamoDB, can be every other provisioned database by the cloud provider. And yeah, this is a very simplified example, but this is how it works. All these services are serverless services provided by the cloud provider. Not just Lambda and API gateway, but with Lambda and API gateway, this serverless term became very popular. And if you think in serverless microservice architectures, you can think of having multiple API gateways sitting in front of some Lambda functions. Lambda functions can be secured in a virtual private cloud environment, and all Lambda functions have concrete relationship to their APIs, so you can spread all your functions to the world. And an example of what I'm doing in my current project is having something like an API gateway in front, and our partners don't know anything about messages, about queues or whatever. They're just sending data via HTTP in our system. The API gateway puts the message, the payload, in Amazon SNS, which is a publish subscribe system. And then again, SNS has subscribers in SQS, for example, and SQS can be connected to an EC2 instance or to Lambda functions, so that the Lambda function can collect the data from the SQS queue regularly scheduled and process the data, put in the data store, and whatever. So very much systems between the partners and the actual processing, and very few lines of code. This is just configuration of all the serverless services the cloud provider provides you. So when you're now using all these cloud functions, all these functions, Lambda functions, what about testing? In terms of unit testing, it's very easy because it's just a function. You have little to no dependencies, a function is stateless, you have some input parameters, and you have a result. So it's really easy to test. But as we all know, only having unit tests is not enough. So you have to do some integration tests. And that's might be difficult. Depends on your use case, how much Lambda functions you're running in parallel or whatever they do. You need an environment, you need infrastructure. And this is only your cloud provider can give you for testing. You can't set up an Amazon environment on your local laptop. So you need to use Amazon Cloud for testing, for integration testing. And currently there's a limit of 1,000 parallel running Lambdas. Might sound as a huge amount of functions, but it's heavily depending on how much data you are processing. And this count of 1,000 is not divided between testing stage and production environment. These are all the parallel running Lambdas on your account. So if you have perhaps 500 parallel running Lambdas in production and want to test a new version of your function, then it might become difficult if you have another 1,000 Lambda functions running in your integration test. There are plans by Amazon to increase this number, but so far you are limited to 1,000 parallel running Lambdas. Yeah. And what about competitors? Because not everybody wants to use Amazon Cloud. Yeah, of course. Google has a thing called Cloud Functions. Cloud Functions by now only support JavaScript, no other languages. And I tested it once, and for me it feels a bit strange working with Cloud Functions because you have to set up very much things to get it running. For me, it was much easier to get started with in Amazon. Also, Microsoft provides a serverless function architecture called Azure Functions, and Microsoft provides JavaScript, C#, Python, and PHP for all of you who like to develop your functions in PHP. And all of them, it's very cool, but you have to do it all in the cloud. Some companies don't want to put their data, their code into a public cloud. So what about on-premise? How can I build it on myself without ending up this way? There's one option, there's IBM BLUEMIX OpenWhisk. OpenWhisk is running in the BLUEMIX cloud, of course, and you can download it and run it on-premise or locally on your computer. It's completely open source, Apache 2 licensed, and you can run JavaScript, Python. I don't know exactly about Java. The official docs don't mention Java at all, but I found 2 blogs. They are mentioning Java for OpenWhisk. So I don't know exactly if OpenWhisk really is providing Java as a possible runtime or not. And IBM is the only one who's providing Swift as a backend language. So they tried to get all the iOS developers to get on their platform for providing backend services for the Apple ecosystem. OpenWhisk also provides some kind of Docker support. You can provide Docker containers as a function, however that will work. And OpenWhisk has something like a function chaining, so you can configure functions which are called after each other. So you can have a kind of reusability, some kind of special authentication, which are used in all your function runs, and after that there's some special kind of logging, whatever what you need. You can build up a reusable function architecture. And to get started with OpenWhisk, just have to clone the GitHub repository and have Vagrant installed. So it starts up a Vagrant box providing all the services. And then you can just write your JavaScript function and run 2 command line arguments, and then you can have it running on your local machine, on your local cloud. What are the drawbacks of all these serverless things? Of course, all the things are getting smaller, and if you have smaller items, you have more items, of course. And you have to document it somehow to know which functions are running, which functions have dependencies on other functions, whatever. You have to do a real good logging and monitoring of metrics. But of course, these all are the typical things for distributed environments. Without documentation, you will be lost. And of course, you have a strict binding, you have a strict dependency on the cloud provider you're using. Because the Lambda function is not compatible with the Google function or Azure function. But if you want to get out the best out of your cloud provider, out of your cloud services, you have to do a binding to your cloud provider. Without this binding, you just have virtualization. If you want to use real cloud services, you have to do a binding to your provider. If you're now curious and want to start with something like that, but you know this very complicated Amazon CloudFront configuration thing, huge JSON documents for configuration, all the systems, the services, the permissions, or whatever, you should give Serverless.com a try. This is a framework. They're saying from themselves they're powered by AWS Lambda. So far, it's only possible to deploy Lambda functions. And you can install it with the use of npm, Node.js, and create some functions and deploy it to Lambda and API Gateway. This is all what serverless.com is doing for you. You're just writing your function, deploy it to the cloud, and serverless.com will care about all the settings in CloudFront and not CloudFront, Cloud Foundation, sorry. You have all the configuration, the permissions. There are creating the permissions, buckets in S3 and whatever, so that you can focus on your code, but not on the configuration of the cloud. Yeah, we saw serverless is not about no servers. It's very powerful because you don't need to spend any time and effort on managing your servers. You can concentrate on just running your your code. You have a minimal effort to do this, and you have a very minimal time to market. So you can start today with some functions and being live in a few minutes. There's a really low costs, so we have a minimal financial risk, and I would say if it gets expensive for you, then you're really, really lucky, because then you have a huge request from your customers. In case it's not a denial of service attack, okay. But you don't have to think about scalability and availability, because that's what your cloud provider is doing for you. If you need more instances of your service, Amazon is just firing up more functions in parallel, up to 1,000. Yeah. Do you have any questions to serverless, Amazon, whatever?
What is your experience with speed of Lambda?
What is my experience with speed? As long as I use JavaScript or Python, interpreted language, it's all okay. Java-based functions need, of course, a bit more to fire the JVM up. That's a drawback when you have Java-based functions. Just interpreted languages like JavaScript, you're good to go. It depends what you want to achieve. If you have just a web API with an API gateway in front, mostly the bandwidth to your customers will be the limit, not the time your function will run. But interpreted languages are faster to start up than Java, yes. Yes?
You said about Java and JavaScript, and you had some pricing table based on the memory you use, but do you know how they relate when using a Java function or a JavaScript function? You have to build up the JVM, maybe it's more expensive.
So the question was, how do the costs relate to use Java and JavaScript? Because with Java you have take some more time to fire it up. No, I don't have experience in that, unfortunately.
I didn't mean maybe the time, but more maybe the memory that is much bigger when using Java.
Yes, you need more memory. That's right. But the functions we have in productions are all in JavaScript. So we don't have an experience what's needed to run a Java function the same way as a JavaScript function. But I could imagine it's a really bit more, yes.
I have a small Scala and that fits in the lowest bracket, the 128. So okay, just a couple of dependencies, then you still find the smallest.
Yeah, I'm sure that the Scala function will fit into the lowest category, but it always depends what you want to achieve. what do you want to process with your data and what do you want to do. Yeah. Yeah. Of course, there's documentation of all this available at the cloud providers. I don't know about the documentation at Google and Azure. I just read the documentation from IBM OpenWhisk. That's pretty good. Also for running it on-premise, what you have to do, I have to consider. And also the Amazon documentation is very, very good. But as always, the Amazon cloud documentation, you have to know about permissions, roles, and all the Amazon resource name things to get it right. Yeah.
What's the price of this? What are the costs in this? Does it pay
So, sorry, once again, the cost? The costs depend on your. I can try to find it online. Depend on the usage of your memory and the time it runs. So no, wrong. Product details. Come on, pricing. So of 1 million free requests per month, and so it depends on the memory, how much memory you want to allocate, and then you have blocks of 100 milliseconds, and then the price in US dollars. So 100 milliseconds are very cheap running. But it depends. If you need more memory, of course, it gets more expensive. And yeah, you can have up to 1.5 gigabyte of memory, and but then you're quite expensive. And I know about another team of my project. They tested it with a huge Java function, and they had to use the biggest possible memory allocation, and but it even won't work. So it was the wrong use case to have a function running in the cloud. Yeah. Every request is it has a minimum of 100 milliseconds. Yeah. So even if your request just needs 10 milliseconds, you always have to calculate 100 milliseconds per request, at least, or in blocks of 100 milliseconds. If you use 101 milliseconds, you have 200 milliseconds. Yeah. Yeah. The logging is just printing to the console, doing just some system out print lines, and it's going to CloudWatch. It's the logging service from Amazon. So if I have can see the logging, and yeah. No, this is the wrong. Was the wrong function. This is our Dynamo service. Oh, arrow loading log streams. Cool. Nice. Cloud is very great. Yeah. So this is my send invite Lambda functions, and there's some logging start request. I think there's no own logging from me. No, just have to try it again, because the send invites doesn't send anything, or don't know. There's no logging from Dynamo Lambda, why ever? Don't understand. But this is the place to look for the logs. Okay.
What do you do for the deployments, continuous integration with Jenkins or something? Or are you doing something for the integration test?
Yeah. Question was what I'm doing with the deployment. We have the approach to fully automate all the things. We are writing our own Cloud Foundation configuration files, these ugly JSON files, and then having the AWS command line installed on Jenkins. And so Jenkins does all the continuous integration, continuous deployment things, bringing it into production. So far, we have no integration testing automated. Okay. Any other questions? One more. Sorry? Are there other users using this functionality? Of course, there are lots of users using serverless, but it always depends if it fits to your use case. As I mentioned at the beginning, it's not the silver bullet for all your problems. It has to fit for your use case. But all the big players like Netflix, whatever, using some kind of serverless functions. Okay, so there are no more questions. Even the time is finished. And yes, I think thank you and have a good day.